All right, hello and welcome. My name's Red. I've been at Indeed for maybe about 6 years now, and I currently work on our social impact team. So my team, my day-to-day team and job is focusing on helping job seekers facing bias and barriers to get jobs, and working on tooling within Indeed to enable that and as well as measure it. But I also serve as the co-lead for the GraphQL Guild for our US chapter, so I'm heavily involved in the GraphQL champions at our company. So today I'm speaking about how we really created this great developer experience for creating new subgraphs and making it really easy to get these into production. So just a little bit personally about me. I'm really into multi-sport. I'm really into triathlon. I'll actually be racing across New Zealand next year in a race called Coast to Coast, so, across the South Island. And I'm also really big into home improvement, DIY, any kind of crafting. I'm all about it. I love it. And this is the closet as I was beginning my renovation and rebuild of it. So it might not be surprising that I'm relating my talk to one of my personal interests. So assembly can be hard, right? And so we're going to a little bit of AI-generated art here for you, but just trying to get across the idea of building flat pack furniture. So I'm sure several of you in this room have experienced that. And it can be a frustrating process, even though you have instructions, you have a helpline, sometimes helpful pictures, sometimes helpful words. But it's error-prone, and it can be painful. However, companies like IKEA who build the flat pack furniture, they use these rebuildable or reusable parts, these building blocks that make up their furniture. So, similar fasteners, as well as, panels that can be easily swapped in, swapped out, and it keeps their production costs lower. And, if you build enough IKEA furniture, you kind of get used to the style and familiar with how that works. So, zooming out a little bit to the larger picture here, if you were in Nina and Mike's talk this morning talking about the evolution of federation at Indeed, basically in 2021, Indeed had the initiative of platformization around backend services. So with this initiative, we were moving to one federated supergraph called OneGraph, and that meant that we really needed to, if we're doing this migration, we want to do it faster, we want to do it easier, and so we needed to make making subgraphs easier. So OneGraph launched in about August of 21. This graph here doesn't start until January of 22, but we don't have super great data for me to show before that. But as you can see, we've had a steady growth of subgraphs, and while we did have some graphs beforehand, as we were migrating to OneGraph, we've just had this steady progression. And we wouldn't be where we were today if we didn't make this process easier and a better developer experience. So as of today, we're, I think, just shy of 300 subgraphs. And I just don't think we would have been successful without creating a great developer experience. So when I personally was building my first subgraph for my social impact team, it took me several weeks to actually get it into production, get it integrated with our Supergraph and the functionality built out. And so when you're talking about creating 300 subgraphs across the company, this isn't a really scalable solution. And so, here just kind of like showing that as we created more of these building blocks, and now we are finally at template creation for these subgraphs, you can today create a new subgraph and deploy it to production with minimal work in one day. So it's pretty powerful. So now, going back to our analogy here, talking about the actual building blocks that we use here at Indeed to build this reusable architecture. And so I'll basically be just taking you through these different blocks, why we have them, and how they're useful to us. So much like building that flat pack furniture, we've got these custom building blocks of the subgraph. So we'll start out talking about, kind of like at the end picture, about standard subgraph creation using Backstage templates. And that's kind of like, hey, this is the finished product. We're going to start with that so you get to see it. You get to be jazzed and excited about what it's actually built out of. We got standard GraphQL runtime libraries, specific, indeed, GraphQL features, such as custom scalars, directives, and other unique enhancements that we've done. We also have automated enforcement of best practices. So these are going to be linter configurations and other industry standard practices that we hopefully apply seamlessly. Also, common CI/CD pipeline deployment, so a consistent experience. And then finally, metrics and monitoring, so tools and techniques for tracking and maintaining performance. So starting with Backstage templates. If you're not familiar with Backstage, it is an open source framework for building developer portals, I believe open sourced by Spotify. So it's just a uniform platform. We use it at Indeed as a dev portal. You can see everything you want to know about your services in one spot. But today, really, just focusing on the templating engine that Backstage provides, which helps us make it really easy to create subgraphs. So templates are basically kind of like hiring someone to come build your shelving for you. Like, you don't want to put that flat pack furniture together. All you want to do is focusing on, customizing it, put your books in it. Similarly, developers probably don't want to spend a lot of time hand-rolling these subgraphs. They want to actually be focused on the functionality that their subgraph is providing. So there is time, energy, effort, money involved upfront to creating these templates, but the more subgraphs that you create, you're reducing that developer toil and that cost. And there can be small maintenance costs of maintaining these templates going forward, but it's absolutely worth the effort that we've found at Indeed. So at Indeed, to create a new subgraph, all you're going to do is you're going to go to Backstage, find the GraphQL template, and go through the process. So here, I have a demo. All right, cool. So here we're creating a new template. So just creating a new project, finding out where we want to have it live in GitLab, and naming it. So pretty straightforward first step here. And then going into a little bit more project setup here. So service ID that we use, as well as a description so that people know what the subgraph's about. And here we have some additional options. So selecting your language, as well as deciding if you want it to be a subgraph or if you want it to be a standalone graph, and whether or not you want some example schema in there. Then here we're selecting some directives, whether or not we want relay node and connection support, and then any custom scalars that we might want to use in our graph. So while we can easily set them up here from the get-go, you're not limited. You can always add them later. Then we are setting ownership here. So we use this in our contact directive. So again, just providing information so that people know who owns this graph. And I'm just filling in some kind of boilerplate information here, since this is not actually going to be a real subgraph that's living in production. Selecting your product group. And then finally, you'll be able to review all of your choices and to make sure before you hit that button that you have all the things that you want. So here, this is Backstage going through and going through all the steps to create that new graph. And some of these steps are not used because they're for Java. Some of them are not used because of the options we selected. So here, just going into GitLab, we're going to clone this new graph down, and we're going to run it. So since I selected Node here as the language, the sample schema there is Scooby-Doo related. So when I bring up the subgraph, you'll see that it's just nonsense information about the Scooby-Doo gang. I'm also not going to show you installing NPM modules. Enough of my life has been dedicated to waiting for that to happen. So here, we're just going to go ahead and start the subgraph here. And then basically, I'll show you that it runs locally. So we've got it running. And then here, right, we're just looking at this Scooby case list. We got some great information here. So the next steps that we take are very manual. They're intentional. You go into our Kubernetes wrapper, you set up a deployment, and then you're going to make any functionality upgrades or changes that you want to the subgraph, because you're not want to put Scooby-Doo in production. And so once that is done, there is an intentional manual step to change your GitLab CI pipeline to deploy to QA and eventually prod. So I'm not going to show you those steps in this demo, but we'll skip back to kind of the end here where we're almost done. And so here I'm going to pull up QA. I did not release this into production. I'm just showing you here that, here that is in QA. And then when we go to our Explorer, this is just a simple health check that I pushed. And we're able to get that in QA. And in terms of actual developer time that took me, it was 5 minutes of my time to get it into QA. All right, so zooming in a little bit, again, looking at the building blocks that we have that make up this template. So we've got standard GraphQL runtime libraries. At Indeed, we don't prescribe what language you have to make your subgraphs in. So we do have about 3 languages or language families here that most of our subgraphs are written in: Java and Kotlin, Node.js, and Python. And if you looked at the composition of all of our subgraphs and what languages we use, the majority of them are Java and Kotlin. Indeed uses Java and Kotlin more than other languages, but also I would say this is due to the fact that we had these backstage templates ready for Java and Kotlin a lot earlier than we had the Node.js templates. So when you have an easier developer experience, developers are going to make choices based off of that. And mainly I just mentioned that we have these 3 languages because anytime you increase options, you increase complexity to the system. And so sometimes we've run into issues because we have chosen to allow a multilingual supergraph. When we were starting out at the beginning of Federation, we didn't have any standardized runtimes. We had multiple languages for each, or multiple libraries for each language. And then as we went through upgrades, like moving to Federation 2, we found it necessary to reduce the complexity and standardize around specific runtimes. As you can imagine, if you have 200 subgraphs and 3 different languages and multiple libraries within each of those languages, and then multiple versions of those libraries that are running, it just creates a complexity. And so we really wanted to simplify things and make it easier for upgrades and improvements to happen as we continue the life of our Supergraph. So that's basically our runtime libraries. And then moving on to Indeed specific features of our GraphQL services. When we started our federated Supergraph, we found it easy for developers to introduce scalars, and so they wanted to do it. Not realizing the impact that it would have for the entire Supergraph, so it led to inconsistencies across graph. We ended up with both N64 and long, and so we started a process to standardize around common names and formats and standards that we'd be using for these. As GraphQL is missing some primitive types, we've defined and implemented those along with other types that we commonly use across our graph. So when we introduce new scalars, we discuss the need for that scalar at the guild level. We talk about how validation for it will work and what language differences that could potentially cause problems when we're using these scalars across graph. And so then that ensures that once we all agree on the scalar and the implementation, and when we implement it, that we're having a consistent experience across the graph. For Java and Kotlin, we've created our own implementations. For the Node library, we've relied on the guild's GraphQL scalar library as the basis of our definitions. And then we've had to rewrite or rename or add to that library in order to make sure that we're matching the Java implementations. And then in order to use the relay node interface, we needed to have a way to use unique global identifiers. So we have the concept of IRI, which is Indeed Resource Identifier. Very descriptive naming. I like simple descriptive namings. And basically, we just have libraries and factories that encode or decode these values based off of context, entity type, and the internal ID. So the libraries encode and decode the information, and then the node API will interpret the entity by decoding the IRI and then queries the particular subgraph for that, and then federation takes care of the rest in terms of fetching the rest of the fields. Why is this so exciting or cool or creates a better developer experience? It eliminates the need to write a bunch of query by identity type by ID and makes it just easier and faster to get subgraphs into production by reducing the number of queries that we need to write. So those are just some of the Indeed-specific GraphQL features. I would not have time to talk about every single maybe possibly interesting directive or enhancement that we've done. But moving straight on to automated enforcement of best practices. So in order to scale high-quality subgraphs, we need to have strong governance and ideally automation around that governance. Ensuring that we follow best practices, as I'm sure many of you here have experienced, can be challenging. The first thing I want to talk about is our API recommendations. So this is a very manual process. So to address the quality of our schema, we have these recommendations. And we have an API design review process in which we review net new subgraphs to OneGraph, as well as any updates or changes to schemas. So this is guided by the API recommendations. And as our Supergraph has evolved over time, these recommendations have changed and evolved as well. However, we want to make these processes automated as much as possible. So we do have a customized ES linter plugin that we do use many of the common GraphQL linting rules, but we've also written automation to check many of our own API recommendations. Not everything is automatable, but as much as possible, we have added to the linter. So we want to kind of look at how this linter works. We're back to the Scooby-Doo gang, and this entity type is a Scooby case, so just one of the many cases that the gang has tried to solve. And the recommendation previously that was up was talking about having IDs be type ID. Very simple rule, often violated. And here, when we change the ID type, or the scalar type for ID here to string, and we run the linter, we get a warning and tells us, hey, fix it, and this is what's wrong. And then, we fixed it here, we've rerun the linter, no errors, no warnings, no problems. So, granted, this is just a very small subset of schema that we have tested, but any violation or warning that you'd have would show up, which is helpful and important information. But then, how do you get people to care? So we've introduced a quality score to subgraphs. Linting is just one part of it. So based off of your errors and warnings, you'd get a score. And then we also have performance, criticality, and resilience ownership that builds out the rest of this quality score. So when you're trying to enforce quality, sometimes naming and shaming can be an effective strategy. As also is giving a concrete number here allows a team to work towards, set concrete goals to work towards a higher number, as well as in our CI/CD process, we are able to gate releasing to production based off of quality score. Another automated best practice that we have is running schema validation. We're just using Apollo schema checks that we're running through Rover in order to ensure that we're not breaking the Supergraph as we're putting up new changes. So here, OneGraph shell, it's just a wrapper around Rover. It fills in some of the blanks, handles some of the authentication stuff, so that each developer doesn't have to have their own API keys and doesn't have to have a full understanding of every single blank to fill in. So we're just running composition checks, so we're making sure that used compositions don't fail. We're not removing used fields or changing nullability, and operation checks. So we're able to run this locally. We run it in our CI/CD process. But anytime that you're able to shift testing left and alert folks of errors and issues earlier in the process, the faster and better that developer experience will be. Another practice we have is overlay. So this is really great. You can test your subgraph in the context of federation without having to run everything else locally. So here you're just running your subgraph locally, you're running one graph locally, and then using our service mesh, one graph will just call out to QA and pull in any additional services that your subgraph needs to get information for. So this allows you to test any schema changes in isolation. So basically you have your own version of the supergraph for testing. So again, it enables you to test changes locally before pushing up. It allows integration tests to easily be run in branch builds and in the context of the supergraph. Our next to last block here that we're going to talk about is common CI/CD pipeline for graph deployment. So for each language that we have in our subgraph or supergraph system, we have a subgraph-specific and a standalone specific configuration to take you through a common path. You're able to customize this as you need, but like out of the box, you get this. You don't have to think about it. You don't have to worry about setting up that deployment. So you might see a lot of the steps in the automated best practices that I talked about before here. So these are basically, this is not every single step, but these are the basic high-level interesting things that we do here in our GitLab CI pipeline. So of course we run our unit tests, we lint the schema, and so here, you're ensuring that you've got that quality, run the overlay, and here you're able to run those integration tests. We calculate the quality score, so that happens on every MR, and here we can also gate on that quality score whether or not this is these changes drop your schema quality under what you would need to release to production. And then this last three things we kind of go through twice, right? Once for QA and once for production. So validating the schema, deploying it to QA, publishing the schema, and then back again for production, validating the schema, deploying it, and then publishing the schema. So, again, you're able to add to this process, but these are the just basic building blocks that you're given straight out of the box. And then finally, we get to metrics and monitoring. So essentially here, it's just a Datadog integration. We've got a little bit of a dashboard here for you to look at with some pretty colors. So here, we just have a common observatory artifacts, as well as, common diagnostic steps, since we want to expedite solving problems. So across SREs, across SWEs, across company, having the same metrics and monitoring for, after you release to production is helpful, because then, if you're spinning up a new subgraph, you're able to compare apples to apples and oranges to oranges, and it's really easy to just, get spun up on a new graph. Or if you're, have developers moving teams, it's a consistent experience cross team. And then, here just got maybe an interesting flame graph. So they, again, just showing that these are going to be consistent cross team, and this tracing will allow us to see where time has been spent, and anyone who has been working with GraphQL at the company can come and look at this and have an understanding, and the same understanding, for our metrics and monitoring, which is important. So those are all of the building blocks that we have implemented Indeed in order to make development faster, easier, and without as much toil, hopefully. And then we've taken these building blocks and cemented it in our template form. So it's allowed us to have quality enforced, and a lot of these have been born out of the bumps that we've had in the road, getting to where we are now with almost 300 federated supergraphs. So I'm hoping that all of you can take some of these learnings back to your companies, and in order to speed the development of your own supergraphs. So I think really the key thing I want you to take away is that increased developer happiness increases productivity, and having this common structure and architecture and deployment really creates a great platform that people want to be a part of. And then from myself and everyone at Indeed, happy building.